My project is titled Combating Urban Heat Islands with Canopy Expansion in Albuquerque's Most Vulnerable Areas. The climate crisis is leading to higher summertime temperatures throughout the world. Extreme heat poses health risks for human life. It is the leading cause of weather-related fatalities and a major contributor to summertime morbidity. In addition to health risks, extreme heat can affect critical infrastructure and is of great concern to government officials and urban planners. Heating effects are exacerbated by the urban environment, where natural land cover is replaced by buildings, pavement, and other surfaces that absorb and retain heat. This effect is known as the urban heat island. According to the EPA, daytime temperatures in urban areas are about 1 to 7 degrees higher than in outlying areas. Solutions to combat UHI typically focus on strategies of improving general vegetation cover, building design, and growth planning. This project focuses on vegetation cover. A 2021 review of 308 studies found that urban green areas tended to be on average 0.8 degrees cooler than non-green urban areas. A 2020 study used the Social Vulnerability Index to study the relationship between social vulnerability and heat-related health outcomes in a spatial context. A 2021 study found that disadvantaged communities bear disproportionate weight of urban heating due to high energy costs of climate control. The Social Vulnerability Index was created by the CDC and ATSDR and uses 16 variables to calculate the vulnerability of a given census tract. The scale of the index is from 0 to 1. An SVI value of 0.85 means that the population of a tract is more vulnerable than 85% of the tracts in the state. My project objectives were to identify census tracts where temperatures are most extreme, canopy coverage is the lowest, and which tracts are the most vulnerable. Then identify tracts where all the above values are within the top 25%, and finally identify land within these tracts that can be used for canopy expansion. My methods were to use zonal statistics to calculate the temperature average of the census tracts, zonal histogram to calculate the canopy average of census tracts, and use the difference tool to remove building footprints and existing canopy from selected tracts to identify land for canopy expansion. Here we have the map of the afternoon heat index. Notice that the downtown and the newer, dense developments on the west side of the river are far hotter than other parts of the city. Here we have the canopy data. I have created a large-scale map to illustrate the detail of this data set. And here we have the map of the SVI values within Albuquerque. Notice how varied the vulnerability can be within various areas of the city. This map identifies the census tracts in the top 25% of values for temperature, lack of canopy, and social vulnerability. These are Albuquerque's hottest, least green, and most vulnerable areas. And finally, we have a map illustrating the land that can be used for canopy expansion to serve Albuquerque's most vulnerable communities. Here is a large-scale map illustrating the detail of the analysis. The red area is the land that is free of existing canopy and buildings, ideal for canopy expansion. Due to the limited scope of this project, there are some considerations for further research. My data does not account for land use, existing infrastructure, or soil type information, all of which are critical should canopy expansion be considered. And as Albuquerque is a desert, any policy to expand vegetation coverage should be mindful of water usage. Other desert-friendly methods of combating UHI should be explored. I would like to thank Professor Yang and Ms. Saragai for your guidance and input for this project. Thank you.